Today we're looking at section 2.1 and we're beginning our look at conditional statements. And our objective today is I can write different forms of conditional statements and I can find the converse of a conditional statement. Now first of all, what is a conditional statement? Well, a conditional statement is a statement that has the idea of if then, and often we'll call a conditional statement an if-then statement. In an if-then statement, there is what we call the P or hypothesis. This is what I call the condition. So this is the condition that must be present, and if that condition is present, then that leads us to what we call our Q, or our conclusion. Okay? So an if-then statement has a hypothesis and it has a conclusion. So for instance, I have the statement, if it rains, then the game will be canceled. So the hypothesis in this is it rains. That's the hypothesis or the condition. It's raining outside. If it's raining outside, then the conclusion will come. The result or conclusion, let's write result here too, of the fact that it's raining right now is that the game is going to be canceled. So this is the hypothesis, and that brings us to the conclusion or result. Okay? Now, if-then statements can be written in basically 4 different ways. You must memorize these 4 different forms. So these are the general forms. The first one is the if P then Q. So the hypothesis is first, and then the conclusion follows. An example of that in geometry would be if measure of angle A equals 60 degrees, then angle A is an acute angle. So the hypothesis is, or the condition is, that measure of angle A is 60 degrees. Then we conclude that angle A must be an acute angle, okay? Because by definition, any angle of measure between 0 and 90 degrees is an acute angle, okay? So that is the first and of course most common form of conditional statements or if-then statements. Then the second one, the key word is implies. The key words in the first one are if, then. Okay? In the second, the key word is implies. In front of implies is our hypothesis. And after the implies is our conclusion or result. Okay? So the exact same statement written in this form would be measure of angle A equals 60 degrees implies that angle A is an acute angle. So the hypothesis, let me do it in a different color, is measure of angle A is 60 degrees. And the conclusion is that angle A is an acute angle, okay? So this is the hypothesis, and this is the conclusion, or the result that we can come to, okay? The third form of conditional statements, and again, you must memorize these. The key terms are only if. If you see only if, what's in front of it is the hypothesis, and what's behind it is the conclusion. Okay? So the same statement, measure of angle A equals 60 degrees. Only if angle A is an acute angle. Okay? So this is the hypothesis, this is the conclusion. Okay? Only if are the key terms that tell you what's in front and what's in back. So, so this is our hypothesis, and this is the conclusion. Okay? Now the fourth one, that is the one that's different. And the key word is if. Okay? Notice it's the key word is just the word if. When it's in this form, it's actually written backwards. The first statement is the conclusion, and the back statement is the hypothesis. Okay? So, angle A is an acute angle if measure of angle A equals 60 degrees. So the key word here is if. So that tells me that the hypothesis comes behind, whoops, this is the hypothesis, and in this case, the conclusion is in front, okay? So, examples. Underline the hypothesis once and the conclusion twice, right? So, our first example is length of AB equals length of BC if B is the midpoint of segment AC. Okay. Well, first of all, we got to figure out what is my key word. So the key word is if. So that tells me I'm using the fourth form where it's written backwards. Okay. So the hypothesis is B is the midpoint, and the conclusion is length of AB equals length of BC. Okay, so if I was going to write this in the standard if-then form, it would look like this. If B is the midpoint of AC, then length of AB equals length of BC. Okay, so that is in the regular form, but in this case it's written backwards. So the hypothesis is first, the conclusion is second. Number 2, angle AOC is a right angle implies, that's my key word there, implies, that's the key word, measure of angle AOC is 90 degrees. Well, that tells me then, because it's the key word is implies, that tells me I'm using this form. So the hypothesis is first, the conclusion is second. So I'm going to underline the hypothesis once, the conclusion twice. Okay, now knowing the hypothesis and the conclusion is very important because very often we want to write the converse of a conditional statement. So part 2 of our lesson today is looking at converse of conditional statements. The converse is created by switching the hypothesis and the conclusion in the original conditional statement. The conclusion of the original becomes the hypothesis, and the hypothesis of the original becomes the conclusion of the converse. So if the original conditional is if P then Q, then the converse would be if Q then P. So now, in the original, this one is the hypothesis. This one is the conclusion. But in the converse, the conclusion becomes the hypothesis, and the hypothesis becomes the conclusion. Okay. Very, very, very important, the next statement. The converse of a true conditional is not always true. So even if the original statement was true, there's no guarantee that its converse is going to be true. So for instance, an example, my conditional is if points are coplanar, then they lie in the same plane. So the hypothesis is points are coplanar. The conclusion is they lie in the same plane. That is a true statement because by definition, coplanar points all have to be in the same plane. So the converse would be if points lie in the same plane, now this is my hypothesis, then they are coplanar. In this case, the converse is true. Okay? Next example, the conditional. Measure of angle x is 110 degrees. Then angle x is obtuse. So the hypothesis is measure of angle x equals 110 degrees. The conclusion is angle x is obtuse. So if measure of angle x is 110, by definition, it is obtuse. So that is a true statement. The converse, so the conclusion becomes the hypothesis, and the hypothesis becomes the conclusion. So the hypothesis now is angle x is obtuse. The conclusion is measure of angle x must equal 110 degrees. This is a false statement because if angle x is obtuse, means that x has to be greater than 90 but less than 180 degrees. So is every angle that's greater than 90 and less than 180 degrees equal to 110 degrees? No. It could be 115 degrees. So this one is false because just because x is obtuse doesn't guarantee it's going to measure exactly 110 degrees. Okay? And so if I say, well, measure of angle x equals 175 degrees. Well, that meets this condition. It is obtuse, but is measure of angle x exactly equal to 110? No. So measure, if angle x is 175 degrees, is what we call a counter example. So it's at least one situation that makes the hypothesis true. the hypothesis true, but does not lead to the stated conclusion. That's what we call a counterexample. And we only have to provide one, but I could provide many. So would measure of angle x equal to 95 degrees also be a counterexample that shows this converse to be a false statement? Okay? Yes, it is. It's another example. Okay, let's look at another conditional. If two angles are right angles, then they are congruent. So the hypothesis is two angles are right angles. The conclusion is they are congruent. Okay? And that is a true statement, because if angle 1 is a right angle, then it equals 90 degrees. If angle 2 is a right angle, then it equals 90 degrees. And if angle 1 equals angle, or measure of angle 1 equals measure of angle 2, then angle 1 has to be congruent to angle 2. Okay? The converse, so now in the converse, the conclusion becomes the hypothesis, and the hypothesis becomes the conclusion. Okay, so in this one, it says if two angles are congruent, that's my hypothesis now, then they are right angles. Okay, well, can we think of a counterexample where two angles are congruent, but they are not right angles? Okay, so think of a situation where two angles are congruent, but they are not right angles. So could angle 1 equal 45 degrees and angle 2 equal 45 degrees? Okay, are those two angles congruent? Yes. Angle 1 is congruent to angle 2. So then, are angle 1 and angle 2 both right angles? No, they're not. So this one is false. And the original conditional was true. Okay? So I gave you here a counterexample. So could you give me another counterexample where angle 1 and angle 2 are congruent, but they are not right angles? So think of one where they're congruent but not right angles. Well, measure of angle 1 could be 30 degrees, and measure of angle 2 could be 30 degrees. Angle 1 is congruent to angle 2, but angle 1 and angle 2 are not right angles. Okay. Then we have what's called a biconditional. A biconditional is formed if a conditional and its converse are both true. That's the key. They both have to be true. Then they make what we call a biconditional. Biconditionals contain the words if and only if, which is the strongest statement we can make in math. So we can write the hypothesis if and only if the conclusion. That would be a biconditional. Note, all definitions can be written as biconditionals. Okay? When we write the biconditional, first of all, we identify the hypothesis and the conclusion, and then we just put an if and only if between them. Once we've determined the statements are true. So line K is a bisector of segment XY. I need to put my segment symbols here. If and only if K intersects segment XY at its midpoint. Okay, so this is a biconditional because it has the keywords are if and only if. And so that means that we can write it as two conditionals that are converses of each other. So to write this as a conditional, if line K is a bisector of segment XY, then K intersects segment XY at its midpoint. Okay, so that would be the conditional. The converse of that conditional would be if K intersects segment XY at its midpoint, then K is a bisector of segment XY. Okay, so there I've taken a biconditional and I've broken it up into a conditional and its converse.